Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. So my name is Purtina Fatiha binti Muhammad Nazri. My matrix number is 1213030. So today I would like to be present about my econometric project, which is the title is The Driving Force of GDP Growth, analyzing the role of final consumption, net trade and inventory changes in 51 countries on the year 2017. So let's get started. This study investigates the complex field of economic forecasting with a specific focus on gross domestic product, which is GDP. In this study, we also only consider GDP, final consumption, net trade, and change in inventory as indicator to analyze the country economic growth. So first, GDP. GDP is considered one of the most complex indicators that express the level of development of a nation and give an exact reflection of the standard of living in a country. So how GDP affect corporate consumption? As we know, GDP is generally used for investment and consumption. In economic, consumption is regarded as the use of goods and also services by a household. In this regard, we can take into account the subsequent categories of consumption, which is private consumption and public consumption, which is these two are the division of final consumption. So next we move on to the net trade. So how net trade affect GDP? Net trade is the entire value of a nation goods and also services exported less the total value of all its import. Therefore, a country net trade make up a portion of its entire trade balance that might influence the calculation of GDP for a particular country. So next, for the last one, which is change in inventory. So the change in inventory refer to the difference in quantity and values of a country inventory from one period to another period. Change in inventory also a broader measure of national income and also economic indicator that often associated with the calculation of GDP. Therefore, it is clear that there are certain relationship between GDP and all the three variables that I mentioned above, which is final consumption, net trade, and change in inventory. Furthermore, in this paper, we will use the simple linear regression and multiple linear regression model based on the regression function, where the GDP is the explained variable, which is the Y, and final consumption, net trade, and change in inventory explanatory variable, which is the X. So next, for the data description part, the statistical data have been retrieved from the World Bank data, and the analysis and model comparison part is carried out by using Excel and also eViews. So the study of GDP across different countries can be implemented through a simple linear regression model and also multiple linear regression model with the GDP as dependent variable, which has been analysis, and three explanatory variable, which is final consumption, net trade, and change inventory in 51 different countries on the period of 2017. So, from the data that we have been gathered, we estimate the relationship and the correlation between the explained variable, which is gross domestic product, as the result, and the explanatory variable, which is X1 is a final consumption, X2 is net trade, and also X3 is a change in inventory. So, the relationship between the variable listed above can be expressed mathematically as Y equal to B naught plus B1x1 plus B2x2 plus B3x3 plus U, with K equal to 3 as an independent variable, and where B naught, B1, B2, and B3 are the regression coefficient of the model, while U as the error term or the residual variable. So next, let's move on to the result part, which is the most important and also crucial part in this analysis. We begin the analysis by conducting the descriptive analysis. From the table shown in the slide, we can summarize that in the perspective of measure of standard tendency, variable GDP, final consumption, and also change in inventory have mean that are significantly higher than the median, which indicate a right skew distribution for these three variables. Meanwhile, the net trade has a mean and also median that are relatively close, indicating a roughly symmetric distribution. Next, from the perspective of measure of variation, all variables show that it has a higher variance and also standard deviation, suggesting a wide distribution of value. So next, we move on to the analysis by conducting the sample correlation between all the variables. So from the slide, it shows that the correlation of GDP with all this explanatory variable, which is final consumption, net trade, and also change in inventory. As for the GDP and also final consumption, the correlation of the coefficient is very close to 1 with 0.98, indicating a very strong positive linear relationship between GDP and final consumption. The positive linear relationship between these two variables indicates a direct relationship, which is a positive sign, suggesting that as GDP increases, the final consumption also tend to increase and also vice versa. Meanwhile, the sample correlation between the GDP and also net trade show that the correlation coefficient is moderately high, suggesting a moderately strong positive linear relationship between GDP and also net trade. It indicates that these two variables have positive sign, indicating that there is a tendency for GDP and also net trade to increase together. Lastly, for the sample correlation between GDP and also change in inventory is also close to 1, similar to GDP and also final consumption, indicating that it has a positive relationship and tend to increase together when one variable increases. We continue the analysis by finding the variance inflation factor, which is VIF, for each of the independent variable of the equation by using the EView software. From the data shown on the slide, it shows the VIF value for each independent variable. As for final consumption, it shows that the variable has a value of 6.017 for VIF, suggesting that there is some moderate relation between final consumption and other independent variable. However, it is not extremely high, which indicates that final consumption is influenced by other variables to some extent. Meanwhile, the net trade has the lowest VIF value among other independent variables, with 1.857 as the value of the VIF, which indicates that the net trade is not highly correlated with other independent variables. This is a positive and also good sign regarding multicollinearity. Lastly, the change in inventory has a value of VIF with 5.151, indicating some moderate relation between change in inventory and also other explanatory variables. Similarly to final consumption, there is an influence of other variables. In conclusion, the VIF result indicate that there may be some multicollinearity between final consumption and also change in inventory and the other variable. However, since the VIF value for final consumption and also change in inventory is less than 10, it is not a high multicollinearity problem. Therefore, we can continue the analysis using the same equation. So next, to estimate the parameter of this regression model, we run the simple linear regressions. So the simple linear regression model was conducted to predict the dependent variable based on the first independent variable. So the output that have been shown in the slide can be expressed in mathematical way as y equal to negative 1.08 plus with 1.6724 times with the final consumption, where y is the predicted value of an independent variable, GDP, and final consumption as the first independent variable, which is x1. As it can be observed from the data above, we know that the number of observations that taken into considerations for this analysis only based on 51 countries, which is n equal to 51. Furthermore, the probability that this model is correct one is very high, which is r squared is actually equal to 0.9754. This can be concluded that r squared in this case is approximately 97.54% of the variability in the dependent variable GDP is explained by the linear relationship with the first independent variable, which is final consumption. However, the slope coefficient for the final consumption B1 is equal to 1.6724. This indicates that the estimated change in the GDP for a 1 unit change in the final consumption variable. In addition, the slope coefficient B1 is positive with a value of 1.6724, reflecting that final consumption and also the GDP have a positive linear relationship that align with our expectation. So, the estimated value of the GDP is expected to grow by 1.6725 unit for every unit increase in the final consumption. We also should consider the multiple regression model estimation, as the purpose of the method is to illustrate the combined influence of multiple variables. So the equation is formed based on predicting the independent variable, which is GDP, based on the independent variable, which is x1 as final consumption, x2 as the net trade, and also x3 as the change in inventory. So where the output have been shown in the slide and also can be written as y equal to negative 4.29 plus with 1.152 times with final consumption plus with 1.682 times with net trade plus with 27.838 times with change in inventory. As shown from the data above, with the number observation n equal to 51, the multiple regression approach will reveal a stronger connection between the variable where the R-square is actually very high with approximately 99.48%, indicating that the variability in GDP is explained by the linear combinations of the independent variables by 99.48%. Furthermore, based on the equation above, we can analyze the slope of the coefficients for final consumption, net trade, and also change in inventory. For final consumption, which is P1, is equal to 1.152, indicates that there is a direct relationship between GDP and also final consumption, while keeping all other factors equal. The predictive value of the GDP is expected to increase by 1.15 units by 1.152 units for every unit increase in final consumption. In addition, the slope coefficient for net trade, which is B2, is equal to 1.682, which is positive sign indicate a positive relationship between GDP and also net trade. As for 1 unit increase in the net trade will influence GDP also to increase by 1.682 units, holding other factors constant. Meanwhile, the slope coefficient for change in inventory is relative, which is B3, is relatively higher compared to other independent variable. Other variable slope coefficient with B3 is equal to 27.838, indicating an increase in change inventory by 1 unit will result in GDP to increase as well by 27.838 unit. So every variable makes significant improvement to the dependent variable prediction. So and the sign of the coefficient match with the expectations. As we noticed from the above analysis, we identified that there is a difference in the slope of coefficients of final consumption, which is B1 in the multiple linear regression and also simple linear regression model. Once the model is multiple linear regression, so the slope of coefficient might be different from the simple linear regression model, because in the multiple linear regression model, there is an additional independent variable, which is X2 and X3, that allow for a more detailed analysis of the relationship between GDP as the dependent variable and also each of the explanatory variable, where final consumption as X1, net trade as X2, and also change inventory as X3, compared to the simple linear regression model. However, several changes might happen when switching from simple linear regression model to the multiple linear regression model, including issue with omitted variable bias. As we know, the omitted variable bias might be occur in this model if and only if we fail to include one or more variable or left out the important explanatory variable in this analysis. However, in this analysis, we notice that the inclusion of additional explanatory variable in the multiple linear regression model helps to control the problem of omitted variable bias that might occur in this analysis. This is because, as shown in simple linear regression and also multiple linear regression model, the simple linear regression model suffer from the omitted variable bias problem because the slope of coefficient of final consumption, which is B1, is slightly higher than the slope of coefficient in the multiple linear regression model. So next we move on to one-sided and also two-sided alternative hypothesis for all the independent variables. So the first independent variable is final consumption. So on this analysis, we assume that alpha equal to 0.05. Therefore, we compute the t-statistic of final consumption by dividing B1 with the standard error of final consumption. Therefore, by plugging into formula, we will get the t-statistic of final consumption, which is equal to 26.4289. Afterward, we calculate the t critical using the formula of t n minus k minus 1, where k is equal to 3. Thus, from the formula, we only need to refer to the t table to know the value of the critical of the final consumption, where the t critical for 1 tiltis is equal to 1.6779. while the t critical for 2 tiltis is equal to 2.012. As a result of the t statistic and also t critical, value of the final consumption, we know that the T statistic actually more than the theoretical, where 26.4289 is more than the 1.6779 and 26.4289 is more than 2.012 for one telltale and also two telltales relatively, indicating that we reject H0 and conclude that final consumption is statistically significant in predicting the GDP. Second independent variable is net rate. Using the relatively same step as the previous one, we begin by computing the statistic of net rate by dividing B2 with the standard error of net rate. Thus, we will get the T statistic of the net rate is equal to 3.2324. Afterward, we calculate the T critical of the net rate by using the previous formula and refer to the T table, and we know that the critical for one telltale is equal to 1.6779 and T critical for two telltales is equal to 2.012. As a result of the T statistic and also T critical value of the net rate, we know that the T statistic is more than the T critical for both tests, which is one telltale and also two telltales, suggesting that we reject the H0 and conclude that net rate is statistically significant in predicting the GDP. Lastly, for the third independent variable, which is change in inventory, to test whether this variable is statistically significant or not, we start by computing the T statistics of the change in inventory by dividing B3 with the standard error of change in inventory. Thus, we will get the T statistic of change in inventory is equal to 12.9031. Next, we begin to calculate the T critical of the change in inventory by using the previous formula and also refer to the table, and then we get the T critical of one telltale is equal to 1.6779 and also for two telltales is equal to 2.012. As a result of T statistic and also T critical value of the change inventory, we know that the T statistic is actually more than the T critical, where 12.9031 is more than 1.6779 and 12.9031 is more than 2.01 for one telltale and also two telltales relatively, suggesting that we reject H0 and conclude that change in inventory is statistically significant in predicting the GDP. Furthermore, to evaluate how effectively the independent variable combine explain the variation in the independent variable, we often look at the coefficient of determination, which is R squared in the context of multiple linear regression. Based on the multiple linear regression output, we know that the R squared is equal to 0.9948, suggests that there is approximately 99.48% of variability in GDP is explained by the linear combination of all independent variables, which in this model, which is final consumption, net trade, and also change in inventory. A high R squared that close to 1 indicates that the model does a good job of explaining variation in the dependent variable of GDP. Based on the graph provided on the slide, we can decide whether to add the quadratic function to the equation or not. Based on the scatter plot shown on the slide, the regression line show a relatively straight line for the multiple regression model. This indicates that since the model is already fitted to the data, there is no need to include a quadratic function in the equation. Furthermore, the point around the graph indicates that if the points are distributed concentratedly around the line, it suggests a strong relationship between the two variables. As can be seen, the points are distributed close to the line, indicating a strong relationship between the final consumption and change in inventory with the gross domestic product, whereas the plots of the one graph, which is net trade graph, disperse far from the line, indicating a poor relationship between net trade and also gross domestic product. Therefore, given a straight line of the regression model and also the statistical significance of the current model, it is not necessary to add the quadratic terms in this model since it's already fitted to the data. So that's all from me, and thank you for watching.